Hello. Just shut the door, gather my mind. What's up, everyone? Sorry for being 2.5 minutes late. I know it might not seem like much, but tardiness is one of the eternal sins in Sweden, so I do apologize. But it's so good to see y'all. It's been, I think, a month since my last stream. Busy as ever, busy as ever. But hopefully today's stream will actually help me get something done that needs to get done. Of course, I'll explain it in a bit, but for those of you who are new to the stream, this is Fusion and Fika. Fika being a Swedish snack break. I don't know the best way to define it, but coffee and a pastry is how it tends to be. I don't know. I don't think ice cream counts as a pastry, but it counts as Fika. We've got, vanilla ice cream, fresh crushed hazelnuts, and rhubarb strawberry jam from the garden. Oh, yeah. Can't go wrong with ice cream. And this is exceptional. So good. How's everyone doing out there? Are we live, first of all? Is this working? Yes, it is. Good, good. We've got a few people out there. A few shy folks. Let me know in the chat what everyone's up to. What are you working on? Is anyone doing any CAD design or have any projects in progress? I'd love to hear about it. Get a pulse on the makerspace, while I also enjoy this delicious ice cream. It was another close call starting the stream. Emma and I found a last-minute Facebook Marketplace post of some 200-liter buckets or containers on a cow farm 45 minutes away. And we thought they would make excellent rain buckets. And we have so many gutters. The house has, I don't know, 1, 2, 3, 4, 5, I think 7 or 8 gutters. So we collected a lot of barrels, strapped some to the roof of my car. We made 2 trips. Safe to say we've got barrels for life now. So that's wonderful. But it also did mean that as it seems to happen almost every time I do a live stream, I'm jumping on my computer, sweating to go live in time. And this time I missed the mark a little bit, but hey, we're here. And we've got some CAD to do. So good. Rhubarb is a tricky vegetable. If you were to just grab it and take a bite into it, it's stringier than celery and quite sour. And not like sour candy sour, just a weird kind of sour until you add some sugar in one way or another, and then it becomes a really good sour. Excuse me. The first way I used rhubarb from my garden last summer, I saw a suggestion on Instagram where you use an osthyvel, a Swedish cheese slicer, to get really thin slices of rhubarb. I guess any vegetable slicer could work, but you know, I had to do it the Swedish way. And you just get these thin strips that look just like a fruit by the foot, for those Americans out there. Sprinkle some sugar on that and pop it in the oven at low temps for 30 minutes or something. Let it cool down, and it's just like a perfect gummy sour consistency. Super cool. And Emma made this jam, added some strawberries as well. So good on the ice cream. All right, Hank, got some ice cream as well. Good to be eating ice cream in company. and Michael making lots of Kaleido cycles using Affinity Designer. I can't say I know what a Kaleido cycle is. In my mind, it's one of those contraptions where you have two panels that kind of spin around and create morphing shapes. A bit of a moire effect, but tell me if I'm wrong, because Kaleido cycle sounds very cool. If it's a bike that powers a kaleidoscope, even cooler. I have some kaleidoscope ideas, but I need to get my hands on a CO2 laser here in Sweden so that I can laser cut mirrored acrylic and do some, yeah. Or I guess maybe I just need to get into some glass work so I can just cut glass. That actually might be more accessible for me right now. I do have a laser coming my way, but it's not the one that will cut acrylic mirror. So many lasers nowadays. All right. Gosh, I'll be honest, I just want to sit here and finish my ice cream, but I do want to touch on the design from last stream. It's a while back, so I'll remind you. Actually, we can take a look. I think this is pretty much right where I left you guys. 1 second. Here we go. This little pitchfork looking thing. This was my approach at making a half-sized Swiffer duster so that you can get twice as much dusting out of a single Swiffer pad replacement and to be a little more delicate with your dusting. It was kind of an evolving design as we went along, but this is what I came up with. And I know this handle looks weird. That's because I decided to come up with this kind of base design that you can slip a handle onto. So here's a net I had designed for cleaning out the hot tub. I'm trying to sell my hot tub. If anyone in Kalmar is on the market, hit me up. But I made a little net so I could fish out pollen and stuff that the regular pool net wouldn't catch. This gray part is being printed with open infill, so I just printed it with like a 30% hexagonal infill, something like that. Anyways, this has the same handle design, and I designed this rather simple handle around it so that I can slip onto different tools. You can swap out tools, swap out handles. I don't know, maybe it's a weird pairing of items, but I just figured I'd start some kind of simple standard in case I keep designing things around this. We'll see. Anyways, here it is, IRL. I did print it out. As you can see, yeah. This bit is TPU, and this bit is PLA. So that's another reason for separating the handle. Get a little nice grip feel from it. Nothing crazy, but it's nice, and TPU, of course, makes it easier to design a tight friction fitting part like that. This is a color changing one, so clearly it's very warm in here right now, because usually it takes a while to change from orange to yellow. But it's pretty much just turning yellow at room temperature right now. Let's see. Oh yeah, 26.5 degrees in here. You know, I'm streaming, the computer's running. I'm gonna open a window, as a matter of fact. All right. Anyways, there it is. It's a little tiny Swiffer duster. I just cut the thing in half, and it's nothing crazy yet, but it's simple and it works. And another reason I have this handle separately from the duster is so that I can do a lot of different modifications and work on a few different versions of the same thing. In fact, I do have another version that I just got off the printer. Same top, but this handle bit is half the size. That way you can stick two of them together and then stick them inside the handle. The idea being that you can have a more of a full duster. These Swiffer dusters are one-sided. Nice. Makes it easier to slip under thin cracks and things, but sometimes you want more of a fully round duster, so that's what I designed here. This one's a bit dirty, so excuse me if I start sneezing. But let's see if we can just slip it on. I could do some revisions still to this design, but the idea was also that you fold it. Let's see. Yes, you fold it this way. Oh no, I want to do it this way. I designed mine so that you kind of fold it taco style, so it does already become a little more, less flat and more like a, what's it called? I don't know. It's a more directional kind of duster. This is the original one. The other one I slipped onto a generic Swiffer replacement, and that one was actually easier. This one's giving me a little bit of trouble right now. And that's, I think, what I would fix on this design. I would probably taper this so that it's a little easier. I mean, it's tapered in one direction. I would taper it in the Z direction as well, so that it slides on a bit easier. Not that it's something you're doing too often, but come on. I think it's also a tighter fit with this original Swiffer, so some revisions are yet to be made, but I think I'll manage this. Maybe. Nope. That's why we prototype, folks. Yeah, the thing is, I originally designed this handle to be twice the size. I came up with this idea later, and I had to make the handle half the thickness. So clearly it's a little weak, and I also printed it with, looks like 2 walls. I'm gonna have to try that printed solid. Oops. Anyways, the idea is that you got it printed like this back to back so that it's going all the way around and to the sides. Basically like this facing both ways. I'll get it to work, but that's that for now. We're on to new things. Sure, I could spend the live stream fixing that, but I think it's more exciting if we do something fresh and new. And it's maybe another more involved project. Sorry, got the cameras wrong again. What's new? Yeah. Today's project is going to be something that I don't finish, but I think we're going to get some interesting stuff done during the stream in any case. But my ice cream is melting, so quick chat check. All right, kaleidocycle. It's a link of tetrahedrons folded from a sheet of paper that rotate somewhat like a smoke ring. Okay. Interesting. And you're making them using Affinity Designer. So is that like a color, you're printing out some graphics on them? Sounds cool. Hey son, Dr. Valium. Welcome to the chat. All right. Anyways, a little fumble there with my latest Swiffer prototype. But I think that's just a matter of print settings. There are different ways. Actually, no. I think I did have the right approach. Um, Gosh, sorry, my mind is fixated by this ice cream. Mm-hmm. So, as I said at the top of the stream, today's project is related to something I actually need to get done, which is a relief because I'm busy. And, well, I've got family visiting in a couple weeks, and I've got a small house, which may or may not be occupied at that time. And I'm not sure, I think I might have mentioned it on the live stream or somewhere. One of my ideas for this small house, I want to make it a really cozy, fun experience. More than just a small place to stay, but actually like a cool place to be inside with all kinds of cool art and little Easter eggs here and there. But also, I want to do some smart design within the constraints of a really tiny house. So, I'm designing my own bed sofa system. And it's not like a regular sofa bed because this thing opens up to be nearly 3 by 3 meters. 2.7 by 3 meter mega mattress. Super cozy. Sleeps the whole family kind of situation where you just throw yourself on top of it. It takes up like half of the entire small house. Maybe more. But then it also rearranges into a regular sofa. You know, when you want space that isn't occupied by a mattress. And my current solution is 3 IKEA mattresses that are basically going to be modular. I'm going to design them so that they can stack and be connected in different arrangements. And I was debating how I'm going to connect these things for a long time because, well, it needs to be something really robust that can handle someone jumping onto this mattress and laying back on the couch and so forth. So I'm gonna have some kind of flap to hold mattresses in different orientations. And at first I was thinking maybe rivets. If you have enough snap-on rivets, those can be quite strong. But they're also kind of annoying to work with. I would have to get some kind of a press. I'd have to get new tools. Can't 3D print it. Big negative. It's a big con, especially if this is going to be something that I'm renting out. I need to be able to replace parts easily. So that one's, not a terrible idea, but I also considered Velcro. Very easy to sew onto my custom upholstery. I'm making custom cushions for these things. So sure, I can add some Velcro. Nice because you can tighten things as much as possible. It doesn't have to snap in the exact same spot. But it also wears out pretty quickly. Again, if I'm renting this thing out, it's going to be washed quite regularly and, the Velcro will kind of lose its strength pretty quickly. Zippers kind of just break all the time. I'm just not a huge fan of zippers. I think zippers need to be majorly redesigned. I know there's definitely brilliance to their invention. Like, absolute game changer. There's a good video on YouTube of the history of zippers. I don't know the details of who released it. I'm sorry, but if you look up a history of the zipper little documentary type thing, maybe it's a 30-minute video. Pretty cool, pretty interesting. Still, zippers annoy me. They always catch fabric on their way open and closed. They often break, and once they start skipping teeth, it just becomes a mess. And very hard to replace if you have a whole length of zipper to seam rip it all off and sew on a new zipper. Quite a pain. I will have zippers on my cushions because they do serve a purpose, but I don't want to rely on zippers for this modular part of my couch where I have to count on guests coming and rearranging this themselves. Too much room for error. So I pondered and pondered and pondered, and, well, the idea came to me. What can I 3D print? What can I easily replace? What can I adjust to make sure it's tight and well-fitting? What's really strong so that I can resist being pulled and tugged and yanked? Buckles. Of course, buckles. Better yet, I have a 3D printer. I can make custom buckles. I can make giant buckles. Heavy-duty super buckles. So that's kind of what I want to do. I want to come up with a 3D printed buckle, not just one that can replace the ordinary buckle. Although, of course, that's a great thing. And there's plenty of designs already out there on the internet, buckle STLs, to replace broken buckles. But I want to make an ultimate buckle that's just super optimized for 3D printing and really strong, as good or better than the existing things. That tends to be my goal with 3D printing. I don't want to replace something unless I can make it pretty much comparable to the mass manufactured version. So, one little, I don't know. Hard to call anything an innovation because everything's been done nowadays, but a cool thing that just popped into my head today and I whipped up before this stream and printed out is this little prototype here. Check this out. It's the buckle, which needs to be strong, needs to be really robust, but it also needs to flex well. So what if the flexing portion was made up of a bunch of ribs so that it's super flexible, but also combined it has the strength that it needs? I don't know, just a random idea I had, but I think it works really well. And these struts all being parallel kind of keeps this top part moving horizontally. I mean, it moves downwards a little bit, but it rather than rotating, it's kind of a hinge design. A little compliant mechanism fun. Everyone loves compliant mechanisms. And, well, this is just a test, so I think I'm actually going to break this now to see how far it bends. Here I was just testing, okay, can I get enough bend to make a buckle? Yes, clearly. But I want to see how strong this thing is. This is printed in PLA also, so my couch buckle, my giant couch buckle is going to have to be ASA probably. ABS ASA is going to be my choice for that. PETG, a little too brittle for flexible parts. ABS works super well. It's what your mass manufactured buckle is probably going to be made of. Or maybe a polycarbonate or some kind of modified. Nylon could be really strong. I haven't printed with nylon for a while, but surely that's an option if necessary. But I think with proper design, I can make an ABS ASA buckle quite strong for my intended needs. But let's do a little stress test on this idea. And also, as always, I have a design background, not a strict engineering background. So if anyone can tell me if this is a terrible idea, if I'm just making a weaker version of a part, let me know. But in my experience, if you make a flexible hinge like this too thick, it really starts to experience significant stress somewhere, probably down here. Even if you fillet it nice and everything, with the nature of 3D printing where it's several walls becoming single walls and things like that, I think this might be, I might be onto something here, especially if I can make this a really chunky, massive buckle. Here I've got 4 ribs, but imagine if this is like a buckle this big and it's got 12 ribs, it's gonna be really strong, right? It can be thicker as well and still like taller. It can be really tall, as a matter of fact. But because this is thin and it only needs to flex in this direction, it'll maintain that really nice flexibility. I think I'm onto something. But I'm gonna go ahead and chop this off so I can overflex it just to see its breaking point, pretty much. Again, this was printed standard too, so, you know, super thin. But let's see. All right. I mean, I'm still flexing it as much as possible. And I'm not seeing any white marks of stress fractures. Like, that's pretty good, right? Someone give me validation that this is not a terrible idea. Now, this is PLA, so it's already gonna start like... Oh, you know what? It does have a stress mark, but look, it's here at the bottom. And this... Well, this is just a test, but this bottom part can certainly be as thick as it needs to be on a buckle. That's actually a really great sign for me if that's where it's experiencing the most stress, and not here on these ribs. As a matter of fact, I think that's the confirmation I need. So I'm gonna start designing a buckle. We'll see how far I get. Another option, sorry. Well, no. We're gonna design a buckle kind of the standard way, like a, you know, the standard clip-on tooth buckle, but there's other options. There's ones where you just press a button on the top of the buckle, which are generally used for weaker buckles. I feel like this is the design used for something that needs to be really strong, unless you get to the more complicated buckles that are like airline seat buckles or those fancy mechanism clip things. But this is going to be easy and simple, and I think it's strong. Yes, this part can be reinforced, certainly, and I think that's what's nice about it. I think it can scale up and down with the principles not changing. I can reinforce it without it becoming too thick and beefy. I mean, another option is just the more standard buckle and just having the tab be super long. It could just be a really tall buckle, because then, of course, it's distributing the flex across a longer length. That's going to be the variable that I can always adjust if I'm running into weakness with my buckle. And I am probably going to make it, I mean, this is already kind of long for your average buckle, and I'm going to make the teeth a little longer than a regular buckle for this sake. There's going to be a lot of testing for this design to get the right amount of tension and flex and all that. A lot of variables that can be played around with, but let's get started. And because I know this is going to take several prototypes, I'm not going to start designing my giant buckle just yet. I'm going to start with a more standard buckle, or even a tiny buckle. I could go for designing the smallest buckle I can make, and then work my way up from there. I think I'm going to go kind of for a middle ground, though, for the sake of making some progress on this very first stage of prototyping. I'm ashamed to say, as often happens with these live streams, I haven't sketched anything out on my sketch pad. It's definitely something I would have done if I was just going about my normal design process. But for some reason, I like just jumping into Fusion when I'm on live stream and jamming that way. You know, I take that. I don't always hit the sketchbook, but in this case. The PLA is just for the test part because it's the easiest thing for me to print, and I figured if this works for PLA, it'll work for ABS or ASA. But PETG and PLA are both really brittle relative to ABS ASA. And really, for me, I'm just using ASA nowadays. It behaves almost exactly the same as ABS, but it's a little less stinky and noxious when printing. Although I'm also just glad to have my printers in a separate building nowadays. Yeah. Back in college, I was printing parts next to my bed in a tiny room. Yeah, probably did some damage to my brain there, and that explains me stumbling and forgetting and joining the live stream late and all that stuff. I can blame it all on 3D printing. Anyways, let's jump into Fusion and just see what I come up with. Yes, ASA, also outdoor resistant, excellent with heat and everything. It's a pretty awesome material. In the earlier years of 3D printing, there was a reason not to use it because it warped so much and was difficult to use. But if you have a modern printer, a mid-range to high-end printer that was designed in the last, I don't know, 3-4 years, ASA shouldn't be a problem anymore. Maybe you need a brim. Anyways. So the buckle itself, oops, I like designing in the orientation that I'll be printing. So I'm going to print this face down. Although this buckle actually, I will be printing it, the buckle and the receiver of the buckle, they're going to be printed in 2 separate orientations. I've already thought that through a little bit. You know what, maybe let's see if I can get the camera focused on the sketchbook, because there are some things that might be easier to explain in a sketch real quick, and just to make sure that I'm not doing any dumb mistakes and having to restart the design. There's a reason that sketching is the wise thing to do. So I'm just gonna turn on the nuke and switch cameras. Okay. Don't mind my other sketches. Also, here we have the mattress that I'm printing the upholstery for. And basically I'm gonna sew on some big fabric loops that I can attach the buckle onto. And that'll buckle onto another mattress. And I'll have to design it so that it can buckle on in a few different directions. Something like that. Who knows? Could change plans at any point, but that's what I'm thinking. So, few things to think about for the buckle. Oops, I've got a bunch of hot glue down there. Let's see. So the buckle itself is going to be printed flat, just like this. Anyone who's been printing for a while probably has realized that print orientation has quite an effect on the strength of a part. 3D prints made with this FDM technique that we're used to, it's anisotropic. It's weaker in the Z direction because of these layer lines. Things are tending to break across layer lines. In this case, that wasn't true. Here it just sheared because there's the skinny part and I bent it that way. But in general, it'll be a lot more flexible and stronger in this direction versus if I printed this standing up, then all of these would be snapping super easily. However, the receiver, if I print it in basically standing up, by having the 2 prints in different orientations, that provides some strength between the 2. And also it's just a matter of the geometry of the parts. Anyways, the buckle, it's going to be standard. It's going to have teeth. There's going to be a bar here, which limits how far the tooth can bend. That's going to do a good deal of preventing overstressing the part like I did in this case. That's why this stick was here in the first place. You want to make sure that this part doesn't bend any further than it needs to, because, well, it's still a 3D print. So even if I make it really strong and flexible, why force it to do things that it doesn't need to do? It only needs to bend enough, that way it can pop out of the socket. I don't know. Socket? Can I call it a socket? I don't know what the actual terms are. Now, a normal buckle might just have one of these things in the middle and the two teeth that both bend inwards. However, another way to make this extra strong for 3D printing is to reinforce the socket with a wall in the middle. So in order to have a buckle work for that, we're gonna need kind of a gap in the middle, and then the teeth. A 4-prong approach. It looks kind of crazy and wide here, but it's just helping constrain the buckle more. So if you got that there, and I should have a separate colored pen, but I do. Where are my pencils at? Here. So the buckle. Boop, boop, boop. Oh gosh, this isn't gonna work. Pencil just looks too much like pen. Anyways, now this part of the buckle can have a wall in the middle. And depending on how I design this and this part, it can kind of help guide the whole buckle in more easily. Yeah. Hopefully that kind of makes sense, and if not, well, hopefully we'll get to that stage of designing today. Because I do need to get this buckle done. I want to make these mattresses pretty quickly. So, 4 teeth. And we're also going to do this whole tongue thing. So it's going to be a really wide buckle. But the thing is, that's totally fine for my use case. I'm designing these buckles on the side of a 20 centimeter tall couch cushion / sofa, so the buckle can be almost as wide as, it could probably be 150 millimeters even. Big buckle, like I was saying. I think it's gonna be fun. But today's small buckle with all these things, maybe I don't want to make it much smaller than this, because I do want to test this multiple tooth idea, and that won't work if these get too small, I think. You could have the male parts of the buckle on the mattresses and the receiving end to connect 2 mattresses together. Interesting. So only having one part or the other. It could be the opposite as well. It could just be I don't know what the word. Sure, the receiving, the buckle, what did I call it before? I thought I had a good name for it, and now I'm forgetting again. Anyways, the buckle receiver could be only on the mattress, and then you can have a kind of double-headed buckle part that connects things together. That's something I'll have to think about. I'm not sure if that's actually gonna help with the design or just add an extra part that's unnecessary, but it's a cool concept. Socket. Yeah, exactly. You plug the buckle into the socket. Thank you. Okay, so let's jump back into Fusion now and start making something. Oh, sorry. I need to set up my key visualizing software so that you can see what I'm typing. And yeah, we opened a sketch here on the top plane. This is going to be a center line because of, I don't think there's any reason to not make it be a symmetrical buckle. And I won't worry about the loop of the, like how the buckle is connecting to the fabric right now. I'm literally just going to design a loose buckle for this prototype. But I do want to work out whatever I can work out. For example, the angle of the teeth and everything. Like, do I want this tooth to have a bit of an in-cut? Then it's going to be really aggressive, and the harder you pull it, like, it's not going to pop out. But I think a regular old 90-degree angle here will work for now. We'll see. Then a little straight section, and then a curve. Little fusion tip, if you're drawing a straight line, you can click and hold, and then you'll automatically draw a tangent curve. It's a nice little tip I've learned for a while. Now this part is where it's sliding into the socket, so we need to make sure that that is further in than its final position, so that this angle hits the socket and that has it all push itself in together. A receptacle, that's a good name as well. Sheath? Sheath sounds weird to me. Not that it matters. It's just about understanding. If we're all on the same page, then we can call it whatever we want. So yeah, this tooth is gonna be really nice and thick because I'm gonna try my multiple tab approach that I showed you. I'm gonna curve the bottom here. I'm gonna have the tooth that the buckle is gonna go against, and then it's gonna be a gap in the middle for the sheath to connect to. And I guess this will probably be a fillet as well, or a rounded part. Let's see. I guess I have to decide how big this test buckle is gonna be. I think I'm gonna go for this. At first I was thinking I'll make it really tiny, but that's gonna introduce problems of its own that I don't really need to deal with yet. Once I have a kind of maybe slightly oversized buckle design working, then I can solve making it bigger and smaller. I think this is the quickest prototyping approach here. This gap I haven't decided yet. Let's just give it a value for now. Start constraining things, that way it doesn't all fall apart. This, I want a good amount of flex, 10 centimeters. Well, see, now we don't want this kind of we want a pretty shallow round here. So maybe this will be a little smaller. Well, I want it to be strong. So the bigger this tooth is, the stronger it's gonna be. So I just have to make this taller, I guess. And I can make this straight part rather short. These, no reason not to make it collinear up here at the top. The gap here, it's going to be the gap of the wall on the pocket, the receptacle, so it can be quite thin, but we're going to maybe make it like a 3mm socket, so this can be like 3.4. Doesn't have to be super tight. We don't need a precision buckle. In this case, a bit of wiggle room is actually going to be nice to make it easier to use the buckle, you know? I might even make this a little taller, because I want the angle of attack here where you're basically going to have, you know, the sheath hitting the buckle. And we can round this part as well, but the shallower the contact angle is, the easier this will all come together. In fact, with the tongues being so long, they can go up beyond the top of this thing. This thing can be like half the buckle. We're reinventing the buckle here, right? We shouldn't use the existing image of a buckle that's in our heads. We should be free with the design process, willing to try something crazy. This I'm gonna make nice and beefy as well. Maybe I'll make it shorter for the initial prototypes, but for now, yes. This needs to be able to flex at least as much as the tooth, maybe a little more. Let's allow it to flex 8 millimeters. This whole thing will make a solid 15. Nice big chunk. This wall is going to be printed solid or mostly solid. It doesn't need to flex. In fact, we don't want it to flex. 5 millimeters should be fine there. This, for now, we're going to make it collinear. Also, sometimes it gets annoying with all these constraints. So instead of just making a collinear constraint here, that might be hard to find and delete later. I know I might not actually keep this collinear. I'm just going to use a construction line instead. That way, if I decide I don't want these to be collinear, I can just delete the construction line. That's very easy to select. Just a little bit of ease of use. Now this tongue, as I said, the taller it is, the more easily it will flex, which is good for longevity, good for ease of use, but we also have to make sure that it's strong enough that it doesn't just come apart and flex out of the way if you pull it too hard. That said, I'm gonna be pretty generous at this first prototype. 70 is a bit much, but well, let's go with 55. On my initial design here, these tabs are 1.2 millimeters, or are they 1.6? I accidentally deleted the file, but I'll just measure it with my calipers. In the rush to get started for this live stream, I deleted my test file. So according to my calipers, it's 1.6. Good. And the way I did that was a bit messy on the sketch, so I think I'm gonna do it on the next sketch. I'm gonna leave this sketch be. Let's select everything here and mirror it. That is a big fat buckle indeed. This bottom part will probably get thicker. And these teeth also seem like they might be a little flimsy. I think I need to learn from my Swiffer mistake here. But let's make it 6 for now. It's just the first prototype, guys. It's just the first prototype. But I actually love the fun, chunky look of this thing. Hey, Melanie. Yes, you missed Fika. I had to finish it all at the start of the stream because it was ice cream with rhubarb yoğurt silt. Very good. Okay. The buckle, we'll do a symmetric extrusion. That way everything stays centered around the origin here. And like I said, this can also get as thick as it needs to be, but for the first prototype, we'll start chill. Although I love the thought of this being like a cube buckle, as tall as it is wide. Once I've finished prototyping this a bit, I'm definitely making a cube buckle for something, not for the couch cushions, but I'm gonna justify a cube buckle at some point. That just sounds way too fun. And I feel like I'll probably end up either having this more angled or some kind of little catch to really make sure it doesn't accidentally unbuckle. But for now, we'll leave it a little simple once again. All right. Yeah, actually, it's a bit sad I don't have my Fika anymore. I need something to do on screen while I'm doing some boring things like saving my design here. Oh, you had your first Swedish strawberries of the year with ice cream. Nice. We popped into a little farm shop that was supposed to have fresh Swedish strawberries, but they were all sold out, so I haven't had mine yet. Let's see. Where am I saving this? Is a buckle a tool? Not really. I mean, it's kind of a tool. I'll save it under my tools folder for now. And yes, I know you guys can't see this. You know how to save a file, and I just like to maintain some secrecy with my save files so y'all don't see all the projects I have on the pipeline. And also so you're not sad about all the things that I'm never actually going to get back to. But Fusion isn't letting me save. It's not letting me create a new folder right now. Some weird glitch. Anyways. It's saved. So, obviously these teeth are not going to flex. 20 questions. I haven't thought of that in a long time. So to make these little teeth, I'm going to first, well, I'm going to project everything here so I have access to all these lines. And basically, I'm just going to echo this curve here. And by that, I just mean I'm going to do a rectangular pattern. Like so. I'm going to set the distribution to spacing so I can precisely say 1.6 millimeters. And a 1.6 millimeter gap between them. I don't know if I did that last time. I think the gap might have been greater than the part, but let's try it. The closer they are together, the more teeth we can have. That's pretty wild. Pretty wild. Let's see if it works. And we can have them going pretty high up, like I said, but we don't want them going beyond the top. Actually, you know what? I'm also gonna offset this and this and take it in 5 millimeters. That'll be the limit on the top end. And the bottom end, it's gonna be the same here. All right, let's see what happens. I didn't even count if this is gonna work. Ah, yeah, pretty good. A little thicker on the last one, but maybe that's good. Oh, and we want to make sure to complete these. I will also be adding a fillet there for some stress resistance. Oh, also especially since it's tapering here. Oh, yeah, we don't want that. Sorry, rewind. Boop, boop, boop. Okay. Yeah, I don't want it to get thinner at the bottom because that's where it's actually undergoing some of the most stress. So instead I'm going to offset this No chain selection. Offset this 1.6. And then it's the same thing. Okay, yes. Now I can pattern it. Let's still go with the, well, now we want 3.2 because we're modeling in the gap and the tooth. Not too different. Offsetting this again. Let's do -4 to get even. Just, I want to see what happens up here at the top when we print this out and flex it. And this tooth, yeah, this is gonna work. Cool. Let's just do it on this one side first. See, now we're cutting this away. This part isn't getting thinner. In fact, it'll get a little thicker because I'm gonna put a fillet there. All right, we'll do a extrusion all the way through. A widget folder. Could be called a widget. Sure. I do have a jig folder. Jigs and widgets. Just a little 0.2. That's what I did on the last design. And it worked out. Although up here I want to do a full round, so that's 0.8, right? There we go. Pretty cool. It's a vibe. Let's select all of these features that I used. I'm gonna hit my mirror shortcut and mirror that. And normally if you select mirror tool first, it's gonna default to faces maybe, or bodies. But if you select the features and then select mirror, it automatically detects it as a feature mirror. So there we go. I mean, I think it's a pretty fun looking buckle. We'll see how well it works. Okay, Anatrom, I'm a beginner at Fusion. I can make some simple shapes and then extrude and chamfer. It's interesting to look at how a professional works. Well, you know, Anatrom, in the end, even advanced design is usually just sketches. It's just doing the same thing. A lot of simple processes stacked together. In fact, if you look at the timeline here, I've basically just done extrusion and some fillets. And I mirrored things. But yeah. Welcome to Fusion, by the way. It just gets more and more fun as you progress. So we can make this a nice round as well. Maybe still want some flat tops. There we go. And then for these teeth, the smaller the fillet it is, the more aggressive it'll be, but we also still want to fillet just to smooth out the whole motion of things. So just a millimeter there. I think that looks good. There's definitely still some refining to do here, but why don't we start working on the socket just to make sure that I'm not making any silly mistakes. And I think I'm gonna approach the socket design from the same plane. There's always several different ways to approach it, but I'm gonna design it from the top here. I want to project, let's see. I kind of just want to project this outline, not all the little tabs. This is kind of annoying either way to have to select all of this. I don't know why there's no chain selection option for the project tool. Fusion is weird in that way. Sometimes they just, oh yeah, we've got that feature somewhere else in the software. You can chain select a sweep. You can chain select a fillet or pretty much anything, but chain selector projection, that's just insanity. Well, you know, I could have reordered. Yeah. Anyways, there we go. I did it. Didn't take too long in this case. I projected that so that I'll be able to reference it for this part. So I'm going to start by making a box that will be this sheath. Is it going to line up here on the edge? I think so. I think it'll line up on that edge, and I think it'll be tangent down here. And we can do a center line because it's going to be centered. And this top part, it's kind of like the bottom here, arbitrary at this stage of the design. Actually, I don't think I want this to be, I think I want it to maybe stop here. Or maybe somewhere in between, but let's do this for now. And you'll see my reasoning in a minute. Now we can kind of start designing this inner housing. Like I said, this here can be 3 millimeters. What was that? A 0.2 millimeter clearance. I might actually want more clearance there. So, lovely thing about Fusion is I can always just leave for a second, come out here, change something. Let's make it 3.6. And everything updates. How lovely. Although now this is getting even wider. I kind of want all the teeth to be the same distance. Or the same thickness. So actually, this thickness should be a multiple of 3.2. What in my design is currently dictating that? This? Wait a minute. Okay. There we go. A little thicker even. Let's just keep making it chunkier. And in that case, I might need to change this pattern. Or does it need to be... Oh no. I'm thinking wrong. It needs to be a multiple... It needs to be an odd multiple of 1.6. Okay. 1.6 times... So that was... Oh, I lost track. How many was it? Well, let's see what happens if I hit 7. Okay, that makes it super thin. So 9. 9 works for now. Oh, sometimes you lose the fusion, the luck of the fusion gods, where it doesn't like how many changes you've made. So we'll have to go back in here and so I did make it thinner. Now let's stick with the original thickness. I just need to make this 11. Still need to do some updating, but nothing crazy. Just that. Yeah. Now all the teeth are exactly 1.6 wide. I like that. Might even like finesse this later on, have it follow the curve a bit and then go down. Because I have a feeling whenever you have a part like this where it starts getting thicker, then you often experience stress on the outside here, which is why I had all these tabs follow this curve. But we'll see. We're going to learn from this. Oh, and here we've got this. All right. Oh, that didn't quite work the same. Oops, oops, oops. I think we have to do this as two processes. Another 0.8 here. Let's see if that does it. No. It killed my perfect round. Well, close enough for now. 0.799. Okay, it's one of those things. There we go. Then I need to make sure to add that extra little workaround. Wait, does double clicking the line work for projecting? Is that what you're referring to? That'll be a game changer for me if it's true. I'm gonna test it. Project, double click. Nope. Not in that case. I don't know if that's what you were referring to, but yeah, doesn't work for projections. Unless there's a feature in the preferences that I need to change. Alas. Let's see, where were we? This is still 3 millimeters, but now we've got a little extra tolerance here. 0.3. We can have some clearance here as well, right? Is it better to bottom out at the top here, at the bottom here? Actually, probably at the top. So let's just make a little tiny 0.1. This wall. It's gonna be super thick. I mean, certainly for my design, that would be nice. Let's see. Let's try that. And this actually should go all the way down. And this, we'll just make it 15 for now. Sort of arbitrary. This will mirror. Maybe it's a little early to mirror, but eh. Oh. And we also need to create. We need to create the recess that's going to press these tabs in. Oh, and that's the reason that this part might be longer. Hold on, let's go back again. Also, I'm struggling to realize why I don't just want this to be super long. I guess it's flexing, it has to flex more. But I feel like it'll work. Then you have a big button here to press. Yeah. We'll see, we'll see. This cutout. Starting to feel a little in over my head, just, or losing the sauce, getting a little lost in the sauce here. This needs to be down here, where it's gonna hit. Needs a little bit of clearance. Maybe this could be collinear. This needs to be 45 or less. Okay. Oh, this needs to be tangent. It's not fully defined yet, but I think I need to jump ahead in the design a bit to make sure I'm doing things right here. I'm doing something wrong, I think. Let's see, extrude here. We're gonna add clearance. Extrude in the other direction as well. Equal clearance. Color my bodies. These will be combined, but I need to remind myself that they're not combined yet. And I could leave the other one gray, but it's more fun with colors. And sometimes I'll literally just use the move command and just to visualize this buckle sliding in, doop, 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 doop. At this point, it hits a wall and starts pressing these teeth in. The angle here is nice and shallow, so that should definitely do a pretty good job of pressing it in. Squeeze, squeeze, squeeze. Up until this point, it's being fully flexed in. Pop. And here it pops out again, locks into place, hits the end here. So maybe this top needs to be taller. We might want this bottom to be the actual point of contact. Okay. Seems okay. Let's go back to this last sketch now and create the top and bottom walls. Well, I actually think it's easier to just do a new sketch. If I just select this, project this, create a rectangle, corner to corner. It's a bit easier. And we can make this pretty beefy too. For now, though, we'll just make it... Oh, you know what? I still need... Okay, sorry. Beep, beep, beep. Back up. I'm going to use the last sketch because I want the opening... I want this opening on the top and bottom as well. Okay, we want to extrude from this top surface. 2.4. And we could make it a join, but we'll just make it a new body for a quick second. Mirror that. As I've explained before, instead of letting it automatically join, making it a new body and then combining it manually after the fact makes it less likely to break if you update things in the future. All right, I think that's actually already a theoretically functioning buckle design. Maybe this needs to come in more because right now it's, well, yeah, we want to make sure that we can press this more than enough to easily open it. I think it'll work though. We can do a section analysis on this center plane to get our visualization back. I think it's nearly ready for testing. If anyone sees any glaring problems, please let me know. Oh, I kind of have an idea of a potential problem, which is I kind of stopped considering how this is going to be printed. Now this buckle, it could be printed, I just said I'd be printing it standing up, which I still stand by, but it could be printed this way or it could be printed this way. And this actually would have less overhangs, except I need to flip this deal here because I made this a 45 so that I could print this way, but this is a straight overhang. I need to make that a 45 so I can print this way. And even better, I can keep them both at 45s. That way it'll work either way in the future. Increase printability. Like, obviously you want a design to print in one way, but you can actually go above and beyond by making a design print in as many different orientations as possible, just to future-proof it if you end up having to design some kind of modified version and have to print it some other way. Angle the underside of the tooth, easier to push it in and it won't come undone by itself. Yeah. You know what? I was debating whether I would do that at first. And my thinking was that I didn't want to angle it because then you'd have to push it. The buckle would have to come closer together before it can come apart. But if it's just doing that on that tiny scale, that's not an actual issue, I think. So you're probably, it's probably a good call. So I have to remember what I was just about to do, but let's actually see if we can do that without breaking things. If we just delete these perpendicular constraints, let's see if it lets us. There we go. Okay. We do want to change this to be 6 in this direction still. And this angle, I mean, it should be really, really shallow. Maybe 75. I will have to add more clearance at the top. Up here. Oops, something broke. Oh, the projection. But I'm getting rid of this anyways. Perfect. This, I'm gonna create the matching opening here. So I'm gonna make this equal. I'm gonna make this equal. I'm gonna start defining this. Angle it the other way, but then I feel like it'll come out more easily. In my mind, that makes it easier to unbuckle on accident. I feel like this could work. Sorry that I misunderstood you, but I am still kind of tempted to try this. Let's see how much it would have to go up. A little less than a millimeter. So if this is a millimeter, make it 1.2 for good measure. Then when you press it together, it'll automatically push out. It won't flex by itself. I mean, the way I'm doing it now, it will basically, the harder you pull, it'll be unflexing itself. What's happening here? Did it select? Oh, it completely imploded. Oh, I forgot to mirror that as well. Huh. Okay, okay. Calm down, Fusion. Let's make sure to just mirror this all together. Hey Jimmy, this buckle, well, not this particular version, but in the end I want it to be a giant buckle to buckle together couch cushions for a giant modular couch bed thing I'm designing. This is going to be a smaller version for the sake of working out my design before I start printing a giant thing over and over again. Oh, and here, of course, we want the void. All right. Yes, now I should be able to print this way. With only this very small overhang. And even if this overhang sags a bit, it's not going to affect the design. So let's start throwing in some fillets, just some final measures. Actually, to make this easier to buckle in, we can add a chamfer here. We can make it a nice shallow angle. Three by 6. Let's see, what does that make this? 2 millimeters to this being 2.4. I'm actually just gonna bring this top down to 2 then. One of those things that I'm absolutely just gonna have to test and see in person to figure out just what the right dimensions are for that, but I think that's pretty good. We've got our buckle. Oh wait, these teeth aren't locking into anything now. That's quite a lot of give that we've got. So if I'm printing it this way, okay. That's a surface that's going to be taking quite a bit of force. And the layer lines are going to be this way. So I can always make this thicker. I just made it thinner, but I'm going to make it thicker again. In fact, well, let's just do 2.4. For the couch, it'll probably be like 5, 6, maybe even 10 millimeters thick. I want to make this foolproof and just super crazy robust in the end. And for that use case, luckily, I have a lot of leeway for how big and bulky I make this thing. But now we have to bring this down, because I wasn't picturing. So actually, we could design the fillet into this to make it very precise, just by adding this circle. Make it contact. We want this. Why not make it nice and round? I mean, it's still touching at just the one point, which is a little not ideal. I could keep a... Doesn't have to be a perfect round. It can actually be designed more to hit this correctly. See, now with this angle downward, if you imagine trying to pull this out, it's actually going to pull the teeth outwards, if anything. So I think that's a good approach. And then when you press the teeth in, it'll push the buckle up automatically. Eh, maybe I'll end up going flat again, but I do want to try this just to see how it handles. Yes, Ridney, I've heard that Italians celebrate Fika a little differently. You do you. Oh, and now it's unhappy here. What did I change? So this I can keep this super steep angle. Also make this a nice big radius. I'm excited to print this thing. It's gonna be satisfying. I mean, once I get it to not just break for some silly reason that I didn't think of. Once I work it out, it's gonna be very satisfying. Ooh, and since I'm printing this upside down, I actually can have full rounds at the top. So we can go all the way back here and change this to how it originally was if I can find the right constraint to delete. I mentioned this, making it easier to delete constraints, and then here we are. Is that the one? What do I need to let me move this line? See, there should really be something here. If you click and hold, it lets you more easily choose different things. But there should be a constraints tab so that you can find all the constraints related to this point. I think there's a somewhere that you can see all the constraints in the entire sketch, but come on. I really hope someone from Fusion ends up watching all my live streams to learn what simple things they can do to make this just a little friendlier. Now I have to delete that line, and it's probably going to break some things, but I'm going to add another constraint now. I can turn these into construction lines, might make things a little easier. What else? This needs to be vertical. All right, let's see what breaks. Oh, not terrible, but still some weird stuff. Yeah, see, why does it... I didn't even change anything to do with that. And yet it changes its selections entirely. There's an add-on to see all the constraints. Interesting. I definitely need to learn about that. Oh, look at that. We can even just stop it there. But no, let's do it this way. Another reason why we don't use the join extrude, we just create new bodies. So even here, when it's overlapping after this change, that's okay. Let's just move forward, see what breaks. What was this? Oh, up here again? Oh, this got a little weird. I mean, yeah, this whole is that all I need to do? Oh no, I was creating this top surface. So we don't want that. We want this, 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 this. Oh. Oh my. Oh, Fusion. But you know what? I'm not gonna. I still love parametric modeling. It's still easier than being completely screwed if you make one mistake. I will take it. Okay, back to this chamfer. Maybe I should just... Actually, I should just sketch it into the design back here. Yeah. We're doing 2.4 here for now. Nice big radius. And the angle here. Mirror it. And change this. Good. Now we don't need that fillet that keeps, or that chamfer that keeps breaking. And we can still go add a little fillet here. Although we might want to, we probably want to do several, like round this out. That seems nice. Let's get rid of this buckle. Close the section analysis. And I've mentioned in other streams, I don't like having a full fillet on the top, but when it's a small feature like this and a relatively small fillet, it's fine. I guess some aspects of my design, it's not the right answer as a designer, but some things just depend on my mood the day that I'm making it. Oh, I've got some weird little cutouts here that I need to fix. Again, this is the prototype, so all these little fillets and things aren't really critical, but who knows? I might learn something from having a physical version of it. Where? Uh-huh, little tiny things. Did that really break something? What's going on here? It can't create that body? Oh, it did create the body. And just didn't recognize it, and now this is probably going to be confused. That's all good. I don't know if it's that constraints are hidden, but it's just... Well, I guess, I don't know. Maybe I forgot where I put a constraint, and I'm just clicking the wrong point. But I'm pretty sure there was a constraint that should have showed up for me. This needs to be a 1.5 here. That doesn't mean it needs to be the case all around, but sure. Doesn't look like it's affecting anything, and fillets on all of these walls should be good for strength. Let's make sure it's on both sides. Looks good. It's gonna be printing standing like this. We've got a little bridge here, but totally acceptable for now. We can round this as well. These walls are feeling a little thin for me, but... Well, you know what? How thick is this? Because I want the 1.444. So this was 1.5, needs to be 1.5 plus 1.444. That's what I would want it to be in order to maintain the concentric fillets, but that's getting screwed up here, and this has got all kinds of weird stuff going on. Oh, did this happen again, or was it the one I forgot to fix earlier? Where exactly is this? Oh, I'm losing it. There. Is it on this side? It is. Okay. Maybe that's all that it was. Maybe I can do my giant fillet. Nope. Too thin over here. You know what? I'm gonna go back to 1. Except on this one. This can still be 1.5, but by having these two different chamfers within one feature, it makes it, fillets. It blends these together a lot nicer than if I were to do all the 1mm fillets and then do a separate feature with this 1.5. Oftentimes that's totally fine, but in this case, it's creating this nicer blend here, as you can see. And I'm still tempted to make these walls thicker. Let's do it. It's just a 3 for now. Well, this is some random number. Why is this so arbitrary? I gave it this specific thickness. Oh, it's because it's a fillet on a non-right angle. So that makes it this weird number, unless I were to change this to chord length. And then that also does some weird stuff. But maybe it's better. It's just one weird little thing there. Let's try it. See, now the distance here. Nope, still the same. Okay, my bad. Okay, I'm definitely like way overthinking this for my first prototype of this design. I'm already getting into like fractions of a millimeter for the sake of making fillets look good. I should not be doing that. Let's be real. Let's just fillet this 1mm. Do I dream in Fusion? I actually can't say I never have. I've got a design I'll share as probably just as a short, but also on things of a puzzle that came to me in a dream, and it's one of my best. Not gonna lie, like I've always. Oh, I still have coffee. I've always wanted one of those Paul McCartney moments. He says he dreamt of the song yesterday. He woke up and was like, "Oh my God, did I write this song, or is this a song that already exists?" And that was me with a puzzle that I dreamt of. So I didn't have a song come to me in my dreams, but I had a design come to me, and that's also pretty cool. I just need to kind of film and make a solution guide for that puzzle, but I'll share it pretty soon. Like, I'm super eager to share it. It took some work to make it work, but it's a cool one. I know that was a joke question, but that was my serious answer. Oh, you know what? Oh yeah, I'm printing this way. Okay, so it's okay to have these fillets. This looks like it's ready to print. Or it's printable. I need to do some fillets now on this body. Just gonna do a quick 0.3, maybe 0.4 chamfer. Let's do 0.4 to keep it nozzle width compatible. I always like to do that to avoid any elephant foot, even though it's compensated on most slicers already. Just a little extra leeway with the design. That's actually all we gotta do for this one. I think that's a buckle. I mean, the ends of this are definitely unfinished. I guess I should add a loop. If it works, I want to at least be able to use this for something. If it just happens to work first try. Which, you know, on these live streams, as scatterbrained as I feel when I'm designing for a live stream, I feel like I make some of the dumbest mistakes I normally wouldn't do. I've had a good track record of prints working first try. Even my little Swiffer thing from last stream, there's some things I could fix, but it works. I've been using this, I've been dusting, and it works wonderfully. The toothbrush holder, which was my first live stream of the year, I think, worked great. I've designed some hooks. I've got a pretty good track record of my live stream design, so let's knock on wood that this buckle buckles first try. That would be awesome. Yeah, okay. Some loops. I guess in that case I do want to make this a little longer. Oh, come on. You know I don't want to do that with the chamfers fusion. Okay. Yeah, let's just pull these each an extra 10. And then we can throw some quick loops in. Although, this one's going to be standing up, so the loop is a little tricky there. Yeah, the design is not fully fleshed out, but I'm very happy with it as far as a prototype goes. Let's project these edges here and make it nice and beefy. We'll do 6 there. Yeah, this bridge is not the worst. But I still... 55mm bridge. Yeah, it'll bridge. With ABS, it would probably sag a bit. Or need good settings. Like, even if something's technically printable, I always aim to make my designs, like, foolproof. So anyone can just hit print. Even if they've got some silly setting enabled, it'll still work out. So... even bridging, sometimes I avoid. Even, like, yeah, I pretty much try not to bridge more than 10, 12mm. Even though printers nowadays can do, like, probably a full 200mm bridge if you tuned it right. But let's see. If I make this 6 and 6... well, I guess I can make it collinear with this. Hello, Vera. That's my niece, Vera, in Idlewild. I hope you're paying attention, Vera, learning your fusion so that you can become a designer someday if you want. A ballerina princess designer. Alright, so, you know, getting a little lazy for the final parts of this design. Yes, this can bridge, and yes, it's a prototype. So maybe you're right, GSU Unlimited. Maybe I let it bridge this once. But for the future of this design, what would I do? I might have some kind of dovetail or some way to make this a multi-part model. Or I could have a hole going through the side so that it's just a very small bridge, and then you have some kind of a loop. But let's just do it like this for now. It looks pretty. We would want to have some nice big chamfers here. Some stress relief. This is not pretty. Sacrificial walls. I mean, yeah, that's one of my first YouTube videos ever, was making so-called custom supports, which were basically sacrificial walls. And I was thinking of something. I guess it might have been this project that I was thinking of early this morning. And I considered that as well for the big buckles. Yeah, might end up being the way I do things. But for this one, I'll let it bridge. Oops. I want to move this up, but it's doing something strange. Um, 6 seems like a fine number here. Okie dokie. I'm fighting so many urges to like make this very silly little detail prettier right now, but it's absolutely not the priority for this stage of a prototype. So I'm leaving it. Will this work? Yeah, should be fine printed in both orientations. Now this kind of around here would cause some problems for the bridging. Oops. I can show you here. Like this buckle, I definitely, for the sake of the design, for like not wearing away a strap of fabric, it would be nice to round it like that. But if we're bridging here, it's getting steeper and steeper until it's like nearly a bridge, but not quite. And that could cause some problems. So yeah, for the final design, maybe I'll go for a completely different approach. We could do another chamfer here. To maintain my no over 45-degree overhangs. That kind of works. And like I said, this is exactly what I was talking about earlier about coming up with designs that work from multiple orientations, because these two parts are going to be printing in a different orientation, and if I can come up with this slot that prints well both ways, then you're creating a more cohesive design. A little tiny 1 degree fillet should be acceptable for this bridge. Anyways, again, totally unnecessary right now. Let's call it. I mean, no, I'm not done. This bottom part, like this wall is super thin, right? Doesn't matter. But these, it should be the same thickness as this buckle, and there's no reason it can't be. It's not affecting. Okay, maybe it's affecting a little bit of the flex, but maybe if I make a tab lower down, hold on. How far back do we have to go to make this change I'm debating? Definitely before these fillets. I think here we can go and try this. So I'm gonna project these, and I'm gonna project this, and these, and we can make this another wall to stop things, and it'll have a little tab here. A little wild, but kind of cool. Another strange feature that people won't understand why this thing looks this way unless they're familiar with all this printing madness. Now I do need yeah, because of the way I designed this buckle that it goes a little up before opening again, this needs to be 1.2 as well. So that's the thing I might get rid of. And I'll probably just test both a 90-degree and this little angle to see if it makes a difference, if there's any reason to keep it. Okay. I don't know. I don't know if this is the right way to go about this, but it's another little thing to test on the prototype. Like, yes, I keep saying that I'm doing way too much for a first prototype, but the truth is the more you do and the more you try, the more you can learn from a single print. And that means less unnecessary printing in the end, which is always something worth striving for. So just a little extra thickness and a kind of a silly little addition, but oh, what is it messing up? We lost some projections. Easy fix. Okay. We still got a 1.6 minimum distance there, so this is acceptable. And now the buckles are equal width. I think it's maybe a nice touch. Definitely some clunkiness going on, but also kind of cool, right? This looks pretty standard, but when you unbuckle it and you see this thing, whoa! That's a cool buckle! For the final design, I can imagine that you would look into printing it laying down. That would be best for the strap hole to survive. Yeah, I've considered different orientations. Printed flat. I mean, it's one of those geometries that kind of is it wants to be strong in every direction. So I might just have to make one. I'll have to make it bulkier than it would normally have to be in one direction because of the anisotropic nature of 3D printing. In this case, if I print it standing up, I think it's just a matter of making all these outer walls thicker and thicker. Eventually it'll work. If I printed it laying down, I'd have to make these sidewalls thicker so that it doesn't snap out that way. Yeah, I'm not gonna pretend that I'm certain of this orientation being best, but I've kind of thought about it, and what I'm gonna start out with. So yeah, this design is pretty chunky. I wanted to not make it massive for the sake of quicker prototyping, but I also had in mind that this is going to be a giant buckle. So let's see. It's nearly 80 millimeters wide. That's pretty big. That's like a airport luggage size buckle. It's not a buckle. It's not unheard of, but it's not a regular buckle. 80 by 80 pretty much. Yeah. I kind of, to be honest, I lost track of the size, but I'm okay with 80 by 80. And like I mentioned, the couch buckles might end up being double that. They could be 160, which would be really cool. But I do have to figure some things out. There's a very high likelihood that we're better off just having two of these buckles versus one giant buckle. I actually don't know. I mean, unless there's no disadvantage to it being a giant buckle in terms of strength and everything, the one advantage is one less thing to buckle, like more simple buckling of this modular furniture that I'm working on. That's a small advantage. You have to buckle one thing versus two things. So if there's any disadvantage, I'll probably end up going with double buckles versus the one big one. I mean, another big advantage, giant buckle would just be fun. So there's that. You should never ignore the fun factor of a design, because I think that's the most exciting part of design, is making things fun to use. Anyways, that's the buckle for today. Let's see. I mean, the last thing I'll do is just align this part for its printing orientation, which is on this plane. Oops. Align this to this, like so. So if you imagine it on a print bed, it'll look like this, the two parts. And yeah, I sense that by having these two parts that are going to be putting stress on one another, I really think there's an advantage to printing them in separate orientations. That way they're not, the weakness of 3D printing isn't compounding, but it's being compensated by the two different prints. That's my hope, at least. I don't have a scientific paper to back that theory, but that's my intuition for now. The next step is to print this out and test my intuition. See what works, see what doesn't. Be brutally honest with myself. If I have to completely redesign and start from scratch, so be it. But this is really fun. I'm really happy with this so far. And actually, I can already imagine doing some things like based on my where is it? On my test spring. Just if you look at how it flexes, I could definitely add some extra thickness to the center of these spikes, because these, if they got pressed wrong, they could snap. They're only 5 or 6 millimeters thick right now. So in the final design, I might make the entire buckle wider so that those are thicker, or make this get thicker towards the bottom. I don't know. Is it worth? Where'd my camera go? Oh, I put it on the floor. Yeah, just if you look at how these tabs bend, there's all of this like teardrop shape, which could be occupied by solid plastic, and theoretically without hurting the design. Maybe it's a little more complicated than that, but I don't mind being complicated if it leads to a better end design. And we'll see if this stress mark here is a problem. I think it's just because of how I'm pressing it. But this whole bottom being thicker is probably going to deal with that problem. And also this is printed with 2 shells, mostly hollow. And it'll be printed in ABS, or actually ASA in the end. My first prototype will still be printed in PLA, just because it's cheaper and easier. And if it works in PLA, it'll work in those other materials and just last longer. All right. We're 2 hours into the stream. Nice. I'm happy with that. I'm satisfied getting this far in the design. I was a little worried we wouldn't have a full buckle by the end of the stream, but we managed just by pure luck of the timing. And I'm thankful that I had real coffee today, not decaf. I needed it. It got me through this, and I don't know. We'll see. I'll have to update you guys in the next live stream, show you if I made any silly mistakes, and if I manage to do another live stream next Sunday, then maybe it'll be this project again. But usually I end up having something else on my mind a week from now. Or I'll be so obsessed with this throughout the week that I'll end up working on it for the next 6 days. But I have a lot to do, so I have to do the cushions for the couch too. I have to do some upholstery, some sewing, which takes me longer than it should because I question every moment that I spend behind a sewing machine. All right, anyways, there I go. Had to get my rambling in for the live stream. Wouldn't be a Make Anything stream without some classic rambling. But yeah, this is gonna go to the printers. I'll probably just do a standard 0.16 millimeter standard settings. I'll increase the walls to 3 or 4 just so that we're not having weakness where it doesn't need to be, but these tabs are just 1.6 millimeters, so 2 walls and they'll already be solid. Yeah, sewing takes a lot of time, and when you do it as seldom as I do, you really question everything infinite times before committing. All right, that was a fun stream. I'm glad I was able to fit one in this week. Thanks everyone for joining. Everyone in the future, thanks for watching it after the fact. As always, leave comments if you have any questions, if you want to point anything out, if you have any suggestions for future streams. I'd still love to critique some of your designs during the live stream. If you work in Fusion and have some design for 3D printing that you've been working on and want to get a second set of eyes on, or just want to get my opinion and don't mind me doing a brutal crit and maybe pointing out every little thing that I would do differently, well, give me a chat in the Make Anything Discord channel. You can find that in the link in the description of just about every video I put out, a Discord invite. And just say, hey, I saw your call to action on the live stream. It's something I've been wanting to do for a while, but a lot of y'all out there are scared to get a critique, I think. It's part of design. All right. Thanks all. I'll see you soon. Take care. Don't worry, be happy. Live your life.